Good morning. Today we're going to talk about logs. Before we get into what that is, I'd like you to take just a few minutes and try these warm-up problems. Figure out what the exponent is for each of these equations. Okay, so let's talk about these. 2 to the x is 4. So 2 to what power is 4? Right, x is 2. 8 to what power is 1? Well, if you do 8 to the 0 power, remember anything to the 0 power is 1. 2/3 to what power is 8/27? Well, we'd have to take both 2 and 3 to the same power to get 8 and 27. That would have to be cubed. 4 to what power is 1/4? Well, we see that we have the same base here. We have 4's, but one's in the numerator and one's in the denominator. Remember, they change location when the exponent is negative. If we did x as -1, if you took 4 to the -1, that would be 1/4. 4 to what power is 16? Right, x is 2 again. Again, 4 to what power is 1/16? We'd need to think about that as being a negative value. If we did -2, remember that if we have 4 to the -2, that's the same thing as 1/4 squared. But 4 squared is 16, so 1/16. Anytime you have a negative exponent, it's going to change the positions. Now, can we do this one just without a calculator? No, we can't, because 6 to the x equals 35 is not going to be a whole number. 6 squared is almost 35, but it's a little bit over, and so it's not going to be quite 2. So do a little guessing and checking with your calculator, see what you come up with. Okay? I came up with 1.984 by doing a little guessing and checking. I would probably start with 1.9 or 1.8 and maybe do 1.95 and just keep going until I got something that was close to 35. But if I put it in my calculator and I do 6 to the 1.984, I don't get 35. I get 34.983. Now, yes, that's close to 35, but it's not exact, and that's why we do logarithms. Take a minute and put these in your notes. What is the purpose of logarithms? They are the inverses of exponential functions. They are used to solve exponential functions, and they give us the exponent. Remember the word inverse here. This word inverse here. Inverse is used to undo something. We undo multiplication by doing division. We undo addition by doing subtraction. That's what that means for the inverse. So logs and exponentials are inverses of each other. All right. So some things you need to understand is what this means. What we have right here, I'd like you to write this down. It's called the logarithm of y with base b. Or read log base b of y is equal to x. This is true if and only if b to the x is y. This is my base. This is my exponent. So b represents my base, and x represents my exponent. We often call this the argument. It's what we're taking the log of. You need to understand that when I say log base b of y, this is what I'm talking about. All right, so first thing we're going to do is we're going to rewrite things from logarithmic form to exponential form. So this first one here, what's the base? Right, the 2 is the base. What's the exponent? Right, the 4 is the exponent. And so this becomes 16 equals 2 to the 4th power. I often think of dropping this log, taking the base over, and kicking that exponent up. So let's try this one. What's the base? 4. So we're going to drop this log, we're going to take this base over, and we're going to move the exponent up. So 1 is 4 to the 0 power. Same thing here. What's the base? The base is 12. What's the exponent? 1. What does it have to be equal to? So 12 equals my base to this exponent. Is 12 to the first 12? Yes. Same thing here. What's my base? It doesn't matter if my base is a fraction. That's okay. This is my exponent. So 4, my argument, is equal to 1/4, that's my base, to the negative 1 power. All right, I'd like you to try a few of these on your own. So pause the video here and try those. Okay, let's talk these through. This is the base. This is my exponent. So 3 to the 4th is equal to 81. This is the base. This is my exponent. So 7 equals 7 to the first power. Again, I like to think of it as dropping that log and taking that base over and kicking the exponent up. Here is my base. Here is my exponent. So 1 equals 14 to the 0 power. Here is my base. Here is my exponent. 32 equals 1/2 to the negative 5 power. If you don't believe this one is true, check it out in your calculator. Okay, so just like we can go from logarithmic form to exponential form, we can go from exponential form to logarithmic form. It's the same piece. Here's my base, here's my exponent. Here's what I'm going to have to take the log of. So I'm going to take the log of base b. That has to be equal to my exponent. So what am I taking the log of? I'm taking the log of 25. Again, here is my base, here is my exponent. So I have log base 10. That's my exponent. This is what I have to be taking the log of. Again, here is my base. Here is my exponent. The base becomes the base for my log. The exponent becomes what it's equal to. Here is what I'm taking the log of. Here's my base. Here's my exponent. So log base 6 has to equal negative 3. What do I have to take the log of? This 1 over 216. I'd like you to try a few more on your own. Pause the video here so you can try these. These are written in exponential form. I need you to write them in log form. Find the base, find the exponent, and write them. Okay, so what's the base here? The base is 7. That becomes the base of my log. Log base 7. What's the exponent? It's 2. What am I taking the log of? So do you see what this is saying? 7 to what power is 49? That's really what you're asking here. Here's my base. Here's my exponent. Log base 50. My exponent is 0. What am I taking the log of? Again, what's my base? My base is 4. What's my exponent? Negative 1. What am I taking the log of? What's my base? 256. What's my exponent? 1/8. What am I taking the log of? Basically, every number has to get used. And so once you've figured out what the base and the exponent is, what's left over is what you're taking the log of. Now, like I said earlier, logs represent exponents. So what this is asking is 4 to what power is 64? Well, there's a couple of different ways to do that. One way is to do some guess and check. So you can try 4 to the first power. You can try 4 to the second power. You can try 4 to the third power. When you get to it, you realize that 4 to the third power is 64. So what is log base 4 of 4? Excuse me, of 64? It's 3. Because what this is looking for is the exponent. It says 4 to what power is 64? Now this one's a little trickier. Log base 5 of 0.2. Well, let's look at it like this way. Log base 5, 0.2 is 2/10. But 2/10 can also be written as 1/5. It says 5 to what power is 1 over 5? Well, we need that base of 5, don't we? But instead of it being in the exponent, so it says 5 to some power is 1 over 5. Well, how do I get that 5 to go down to the denominator? I have to make it a negative exponent. So the answer to that one is -1. Okay, well, let's take a look at this next one. It says log base 5 of 125. We want to know what power, 5 to what power is 125? So 5 to what power is 125? Again, you can do some guess and check if you don't know for sure, but what you'll find out is 5 to the third power is 125. So log base 5 of 125 is 3. Here, it says 6 to what power is 136? 6 to what power is 1 over 36? Well, 6 squared would give me 36, but how do I get that to go down to the denominator? Again, if it's an opposite sign, I can move it. So 6 to the -2 is 136. So what is the answer to log base 6 of 136? It's -2 because that's the exponent that I use. I'd like you to try these next two. So pause the video here and see what you can come up with. Okay, so this says 32 is 2 to what power, or 2 to what power is 32? Again, if you don't know, you can do some guess and check. But what you'll find is that 2 to the 5th is 32. So log base 2 of 32 is 5. Log base 3 of 1/3, what did you get for that? Here's my base. It says 1/3 to some power is 3. Well, they're the same bases, but I need this 3 here to move up. How do I get it to change places? Again, I've got to have a negative exponent. If I take 1/3 to the negative first power, I end up with 3. So what is log base 1/3 of 3? It's -1. Now, our calculator can help us with some things. If you look at your calculator, if you look on the left side of your calculator screen, you will see an LOG and you will see an LN button. The LOG button is the common log. Its base is 10. So if you ever see a log written like this, you know that it has an understood base of 10 right here. We don't write it, but we know that it has an understood log of base 10. LN stands for the natural log. Yesterday we talked about E, and the understood base for the natural log is E. But again, the calculator already does that for you. So all you have to do to figure out log 8 would be to put it in your calculator. So you hit the log key, it's just to the left of the 7. You want the log of 8, so you're going to put 8 in. And when you do that in your calculator, you get 0.903. Rounded to 3 decimal places. 0.903. That says if I took 10 to 0.903, I would get approximately 8. Same thing with a natural log. So you're going to use the natural log key. It's just a little to the left of the 4. Do the natural log, put in 0.3, hit enter, and you get that this is equal to -1.204. If you took that value of E that we came up with yesterday and took it to the negative 1.204, you would get approximately 0.3. Okay, I'd like you to use your calculator and try those two for just a minute. Pause the video here so you can do that. Okay, so log base 10, remember, but we just say log of 12. So again, we use our calculator, log of 12 is 1.079. The natural log of 0.75. Compare that answer with your side partner. You should have gotten approximately negative 0.288. Okay, we have a couple more properties to look at before we're going to be done today. This is the property that we're going to look at. It says log base b of b to the x equals x. So if these two numbers are the same, whatever exponent is here is your answer to your solution. That should make some sense, because if I rewrite this in exponential form, log base b is equal to x. This is my base. This is my exponent. So this side over here becomes b to the x. But what was I taking the log of? I was taking the log of b to the x. B to the x equals b to the x. That would be true for any value of b, because you'd have the same number here, and any value of x, because you would have the same number there. Make sure you get that written in your notes. Okay, so let's look at one. We want to simplify log base 5 of 25 to the x. Now it's almost like that one, but are these the same base? No, they're not. But could I write 25 as 5 to some power? Yes, I could. I have this as log base 5 of 5 squared to the x. So this becomes log base 5. Remember, when we take a power to a power, we multiply, so we have 5 to the 2x. Now, do I have the same bases? Yes. So what is my answer? It's this exponent right here. The key here is to make sure that you get those two things to have the same base. You try this one, please. Okay? Compare with your side partner. What did you write 81 as? Right, 81 is 3 to the 4th power. But I still have that to this x. But again, remember power to a power, so I multiply. Now my bases are the same. Log base 3, I'm taking the log base 3 of 3. What does that have to equal? It has to equal that exponent. It has to equal 4x. Okay? You try these two now. Do we have the same? Do we have the same base? If you do, then what is it? If you don't, what do you have to do? Pause it here so you can look at this. Okay. Same base. Log base 7 of 7 to the negative 3x has to be what that exponent is. So negative 3x. Log base 2 of 64 to the x. Is 64 and 2, are those the same base? No, but we can make them the same base. We can rewrite this as log base 2 of 2 to the 6th power. And then we still have that to the x. Log base 2 of 2 to the 6x. What's my exponent here? Because my base and what I'm taking the log of are the same. It's 6x. Okay, now I'd like you to pass out a half sheet of paper, or if you just have a piece of notebook paper that you want to use, that's fine. But I'd like you to take a minute here, and I'd like you to answer this question. I got stuck with, what did you get stuck with? I'm not sure of, what are you not sure of? Or I made progress with, what's something that you made progress with? Take a few minutes, fill that out. Okay, would you make sure that your name is on those? And would you hand those in, please, for me? So for tomorrow, or the next time we meet, I would like you to do page 314, 1 through 24, all.